Okay, my extremely good friends, it's Roger once again, and today we're going to start the new website. Well, it's the old website, but we're going to restart it. And this time we're going to have some rules that will apply to everybody that wants to comment, because it got out of control last time, and we'll discuss that later. But what you're looking at right here is more or less of a compilation of what we do at Mudfossil University. And we do a lot of, as you can see in the background there's some anatomical looking stuff. We obviously do that. And you can see the mud fossils. This is literally a new species, and we discovered all kinds of things in the fossil record, using chemistry and understanding the mud fossilization process, and it's coming in from all over the world now. Additional to that, we have discovered a bunch of things about the atomic structure and the nucleus and so forth, which was never understood, and it's called electron flood theory, and I'm going to go through it in great detail for the 1000th time at least. And it accounts for literally everything, for the corona heat of the sun, millions of degrees, and on the surface only 6,000, for our magnetosphere, our ionosphere, all the heat that's way out there, and it's 100 degrees or so on the surface, fully understandable. Schumann frequency, fully understandable. Lightning, magnetism, gravity, fully understandable with electron flood theory. Now, I'm just going to make a couple of quick statements, and then we're going to start looking at bits and pieces. Now, we're going to go as deep as CERN has gone and beyond what CERN has done. Yes, that's exactly correct what I'm saying, and you'll see that in 1 second. They have decided to look at the nucleus of atoms to try and crash them and smash them into the tiniest bits and pieces. However, the tiniest bits and pieces are light. Well, we started with light, as you will see in a second, and then we broke that light apart and we're able to see the photons. And then we broke that apart and we were able to see fermions and bosons, and the boson or the muon is literally dark matter. And I will show you this, and they have never realized this. An electron is not just a negative particle. An electron has also a dark matter particle attached. Let's look at that. But we're going to go through this little bits and pieces at a time. Now, this is going to be day 1 of the new website, and we're going to start with matter. Let's start. Okay, my friends, Roger with his big ego. I had somebody attack me about my huge ego. Well, all I can do is make my statements. They've been dismissed, I've been demeaned, I've been despised, so I don't care anymore. I'm big ego, who cares? This is what CERN is doing. Now, what are they doing? They're taking 2 nucleuses and smashing them together and then digging through all of the debris. And here's the deal, hold on. Nothing is ever where it's supposed to be when you want it to be where it's supposed to be. Here's what was supposed to be where it wasn't. Now, here it is. Now, what is this? That is a nucleus. You say a nucleus of the smallest particles there is. What they're doing is they're shooting 2, what they think, I believe they're calling them protons, neutrons, whatever they are. And they're banging them together. In my world, they're hitting 2 big chunks like this together. What Rod and I did, we took one of these particles and shot it through the venturi. And then we got the same patterns, exactly same patterns. But we're only starting with the smallest particle there is. They're starting getting chunks like this all over. They're all over the place. And then they're digging through and saying, what is this? What is that? What is this? What is this? Ooh, look at that. What is that? Well, same thing, Higgs patterns. All right, you saw what they did at CERN. They took two particles, slammed them head on. What we did was we took the red laser, or whatever laser, you can use any color, and when you shoot it through the venturi, which is here, two like airplane wings, forcing these particles, which are tiny little particles, they look just like this, before they concuss, and then the black and the white explodes, and the black just walks away, and the white just is the concussive part. What we see is photons, and then they break to electrons, and then they break into their bits and pieces, and only white is here, and only black is out, surrounds it. Now, let's see it actually happen, because we can see this. Rod Warren did this over in Australia. Now, this is a red laser. And it's a pulse red laser, just from a, I got one here somewhere, exact same one, I did the exact same stuff he did. Now, what is it doing? It's concussing through the air, forcing everything in front of it because it's pushing its way out in front of it, which you don't realize. And they're all getting excited because they're getting pushed. It's always push to shove. And the harder you push, the exciteder you get, and the exciteder you get, the glorier you get, and the glorier you get, the whiter you get. And that is about as white as it gets. And why is it getting excited? Well, here's that same wave we saw a second ago. And there's the particle which was within the wave, I'll show you in a second, which is going to be just like this. And then it concusses here, and it has to accelerate to go through the venturi. Just look it up, venturi, it's fully understandable. Now, and then they display their particle nature, and here's what they look like. Right there. Dark matter and explosive white matter. Now, here is, and now I'm going to show you this in serious detail, because over here is those electron showers. Those are the electron showers. And that's from coming here, they're coming at us, and here they are. Now, this is all you really need to know about electron flood theory. The current theory, we're just going to take hydrogen, is this one gigantic proton, and it's, now they say, oh, it's made of quarks. Well, no, it's not. But we'll go further. They say it's just one big gigantic proton, and it's about 2,000 times bigger than the little bitty electron out here. And this is totally positive, and that is totally negative. But they have the same charge. Totally wrong. That's the current theory. Absolutely 100% wrong. Now, what is right? Electron flood theory, obviously. Now, what is obviously right about electron flood theory? Electron flood theory says that the core of every atom is going to be primarily dark matter, which is this black spot. And then surrounding that black spot is going to be the explosive concussive part, which we would call the electron. All right, so when they look at it, they just say, well, it's just an electron. That's because they missed the dark matter portion, which is in the center of the explosive portion. Now, this is what an electron looks like. They never have seen the dark matter. Nobody's ever seen it. They just missed it. The electron is in here. The particle nature of the electron is deep, 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 deep in the center, and it controls an enormous, absolutely gigantic region around itself magnetically, just the way magnets do, the real strong magnets. Now, hold on one second. Let me show you what the nature of a nucleus is. It's exactly like you're seeing here. We're going to see black, and then we're going to see white surrounding it. And here it is right here. Boom. You see it? You see the white surrounding the black? That's because this is a charged mass of particles. If it wasn't charged, if it was just like this bone here, I put it up here, it doesn't do anything. Just shadow, it gets a shadow there, that's all. Alright, like this block of wood doesn't do anything, you just see the shadow. But this has its particles arranged in such a way that the white surrounds the dark. and the dark is the dark matter. And every atom is arranged in that way, exactly like that. And 1,837 electrons, which we see as these are electrons, 1,837 of them are actually inside that proton. At 1837, it becomes stable. And the stability is because the whole universe is shaking at 432 hertz. That's what they say. And there's 3 distinct hertz, very low hertz. 432, I think it starts at, that's the golden mean or whatever they call it. But the universe primarily consists of hydrogen, they say. Hydrogen is just the smallest number of particles that can congeal together because of this 432 hertz. Is shaken, and boom, it locks in. At 432, I believe, you get your hydrogen. And once that particle is made, it's pretty stable at that. Now, you could maybe shake that apart with enough serious frequency to actually deconstruct it. And they do. They turn them into ions and plasma now. And plasma is nothing more than shaking the electrons out from the nucleus. There's 100% electrons. There's nothing but electrons. That's electron flood theory. So, just to finish up on this, to show you, the photons are nothing more than electrons back to back, and they are really neutral. When they bang into you, photons, which is light, they just bounce off of you, and then they come back at you a little less than what they bounced off of, because the impact is going to absorb some, and it bounces back. So it might come in purple or blue and come back green. It depends on what it hits. If it hits something very absorptive, you're going to hardly see anything. If it hits something really hard, like a mirror, you're going to get just basically what you put in. Now, the colors are the bounce frequency of the matter that it hits. So there's an interaction there. Let's leave it at that. Now, electrons and photons they just light you up. They warm you up a little bit. They brighten up your day. They just do nice things for you. Well, electron a little different. Electron is a half of a photon, and it is very, 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 very reactive. It wants to be part of something. It doesn't want to be alone. It wants a partner. And so what it does when it hits you, it has to work its way into your tissues. Now, how does it do that? Does it invade as just a piece of warmth, where it takes in an extra electron and it lets it sort of just warm up things? Because that's all it is. When you flood things with electrons, you're just warming them up. Well, when you flood them with too many electrons, a whole batch of them, at a very high impact voltage, because we're going to go over this in a minute too. Hold on. Get the kids, because I'm going to teach them. I know this extremely well. I'm going to teach them all about current and voltage and amperage and resistance and how all of this works. The strong force, the weak force, DC current versus AC current, all of the components, transistors, diodes, Zener diodes, capacitors, resistors, inductors, everything. We're going to go through everything. And it's simple. It's very, very simple. I'm showing how to use meters, how to use a voltmeter. Very, very simple to use. What's the difference between amperage and voltage and resistance? Also, very, very simple. We're going to get into all of this, so get the kids. This is what we're going to understand is the particles that make everything up. Once you understand the particles, then you can see what happens. How does this lightning happen? Why are these sprites happening in the atmosphere? Well, I can tell you why. There's too many electrons being absorbed by the scrubbing layer, and then they are trying to get to Earth, but the Earth is overcharged. That's why we're so overheated. And it doesn't want them. It says, "You keep them." And it says, "Well, we can't. Too many, too many, too many." He says, "Well, then shoot them back." Boop, they go up as red sprites, trying to get away. Normally they come down as white lightning. Well, it's just trying to float off and get away, and it can't. So then they trickle back down as you know, they go up, well, I've shown it a million times. They go up and they create a ball of just explosiveness up, and then it trickles back down because they can't accept it. So we're going to go through this. That's the particle, whoops, that's the acceleration, that's the venturi, that's the electron showers. They like call them electron neutrino showers. That's what they call them. That is, the black ball is a muon, or a boson they call it. The white is the fermion, or it's literally the electron. All right, and it spins. You see it spinning to the right, means it drifts to the left. We can actually see it slowing down. You see it slowing down up here, sped up down here. Now, Rod Warren, like I say, did these shots, and this one here, look at this thing. I don't know what that is. That, I think, came through as a reverse spinner, and that's about all I can say about that. Now, let's go a little further. Okay, this is literally stunning. This is, you saw the electron, you know, the photon, and then you saw it deconstruct and come through as the, and we're going to see it in extreme detail in a second, and the black balls walked away from the white balls. Originally, an electron is just a black ball of dark matter. Nobody's ever seen it. It doesn't interact. It doesn't absorb. It doesn't emit. It doesn't reflect. It doesn't do anything. You would never see it except for the acceleration that we did. Now, the electron has 1,837 of those, makes up one proton, and at that number, that quantity, it becomes stable. And another 1837, it stabilizes again. Another it stabilizes again. That's how you get your hold on. That's what happens here as it goes up and up and up and up and up and up and up. These are more and more and more and more particles. Now they say every one of them is a proton, but then they throw in a whole bunch of neutrons, which is nothing more than a bunch of more particles. Because all these do is make particles, and they're pretty stable at 1837, only it's not neutral. 1838 is a neutron, stable. 1837, not stable. And this is, you may be 1840, 1842, 18, right in that area, I'm not sure. But you also have to understand, there's isotopes. Now what is an isotope? An isotope means that you have one of these things here, one of these atoms, but it doesn't have the right number of particles. It doesn't have the right number of particles in a nucleus. So it's an isotope. And that all that means is we've got nucleuses that don't have 1837 proton number in that one proton. It might have 1835. So it's not quite stable. That's when they talk about stability. So if they say it's a stable isotope, that means it's not going to fall apart. You know, just like the Sirius one here, these are pretty solid. They don't fall apart easily. They bond and so forth. But normally they don't fall. It just deconstruct. However, when they don't have the right number of particles in them, that's when they deconstruct. They just fall apart. That's what they call about stability and, you know, how long they last. All right, now don't forget, there's the pulse. We're going to be looking at the particle right here as it approaches the venturi, and then it falls apart. There's the particle. So prior to before it hits the venturi, you can't see it. It looks like an Oreo cookie. It just doesn't have any real definition to it until it starts to concuss. And then you start to see this very, very shortly before the venturi. And then it just goes into obliteration at the venturi. It turns into all particle, you know, the black and white particles. And then they separate from each other. The black one and the white one walk away from each other. It's just unbelievable. That is the dark matter. And there it is for the 18 billionth time. There's the particle. There's the dark matter. There's the dark energy. Those little black balls, they just walk away. And they will touch each other. They don't care about being next to each other, but they don't want to be involved in this interaction here. They walk away, and then sooner or later, after this concussion occurs, at the venturi, and you can tune this. You can use different materials. You can use different architecture to create whatever you want here, and then you can use different gases. You can do all kinds of things that nobody's ever considered. And what do you get out of here? Right here, you got some kind of energy. Now, this is like a zillion times more powerful than here, and that energy should be able to be harvested. And what would happen if you had nitrogen here, and that was what you were shooting the light into, or oxygen, or helium, or neon, or something extremely reactive? Now, how would you siphon this off? That's a matter for some engineers. But I can tell you right now, there is no question whatsoever that has accelerated, excited, gained energy. And this is nothing. It doesn't turn, it doesn't spin, it doesn't do anything. It's just two round devices that go just like this. And these balls come in and they have to crush into each other. Huge interaction of energy. Enormous interaction. Now somehow if there was a membrane here that wouldn't allow the stuff to go through, and you diverted it off somewhere, who knows? I'm just saying, nobody will engage to look at this, so who the hell knows? Nobody's ever going to know. Just so you know, the green ones do exactly the same thing. That is what a photon is, and that's light. Half of that, just like that, the black and the white, is an electron. And the electron fuses with things. The light pretty much bounces off. It's going to disturb what it hits. Yes, absolutely. And if it's hitting intensely with light, you're going to create some heat because of the concussion of it. Absolutely. But when you're shooting electrons, and nothing but electrons, you're going to cause damage. They are going to try to incorporate into the material that they hit exactly the way static does. Ooh, I get static. Electricity, I just got electrocuted. That's what you got. Lightning, not a good thing to get hit by. Okay, I'm not going to go too long today, but we're going to go into states of matter. And traditionally, everybody knows you have solid things, you have liquid things, and you have gaseous things. Everybody understands that, I'm sure. Well, there's also what they call a fourth state of matter, which is plasma, which is the ions and electrons, which I was showing you and which I will show you. And they have been doing experiments in space that are stunning and show exactly what I've been talking about, electron flood theory. Now, in addition to that, they have what's called the Bose-Einstein Condensate, which is nothing more than having no electrons whatsoever extra in that matrix of particles. None whatsoever. They're all completely gone. Electrons are heat. You force electrons in, it gets warmer. You pull electrons out, it gets weaker. Now, this is electron flood theory, and energy is simply impact and friction. That's all it is. Every single time. It can create electricity, yes, but it's always from impact and friction. Now, what happens? It's a zone violation, really. The electrons own a zone. Now, either they will, the matter owns a zone. Okay. Either they will accept energy if it's cold and they want energy to come in, electrons, to warm it up. Yes, they'll accept them. They might reject energy. It's too warm already. And it's trying to get the electrons to come in. It says, no, get out of here. We got too many already. That's what's happening to the Earth right now. The Earth is overcharged, too many electrons, and when they're coming in, they're not being accepted the way they used to be. They're creating a lot of heat in the atmosphere. They're trying to be discharged back up with sprites and everything else. Now, sometimes the energy can be ignored. Now, light has no set speed. Absolutely not. You can accelerate it, you can slow it down. Now, this was wrong. I think it's wrong. I said light could be larger bits, the red, green, and blue, but I don't think that's true because they're all made of electrons. And I can see the green and the red have the same exact characteristics, so I'm going to go with they're all the same particles. It's just one of them is spinning faster than the other. So here you go. Out here is your red, because it's only spinning like this. And if it bangs into something, well, not a big deal. But if it's down here spinning, and it smacks into something. It's like a drill bit hitting it, slam, boom. So that's the difference, I believe, in the energy levels. It's strictly because of the spin rate now. And I can see it spin. We have pictures of the light eye literally spinning. Now, I am going against Einstein, his E equals mc squared, and I'm, confronting it with electron flow theory. And, I'm sort of saying what the problems, and E equals work, and there's no problem with that. I'll go along with that. Energy is work. M is the mass. I have no problem with that. The problems I do have is the speed of the mass. Speed of mass, I have no problem with that. Okay. But the reason to square it, no, absolutely, there's no reason to square it. That's just to throw in obfuscation. It's just the speed it's going and the weight it weighs, and when it concusses, how much work that can do. That's what it is. For Albert Einstein, light never changes speed. Therefore, everything he said was meaningless. The same number always. Why? It's not. It's not the same speed always. Obviously, you saw it accelerate, and we know it can slow down. And then, anyway, get your book when you're doing this. The reason I'm showing you this, make sure you write down these things. Know what you're talking about. When you go back, look it up and see what you had to say about it. Because there's a lot, you might as well document your own progress of intelligence, because I'm going to tell you right now, if you go to school and you just say, oh, I learned this, I learned this, I learned that, well, you just wasted your time, and at some point they're going to say, oh, you learned all wrong stuff, because you did. I'm sorry, that's a fact. Now, if you want to confront what I have to say, I love it, but I need to have you confront everything that I say with some material evidence, not just, well, Mendeleev said this, or Newton said that, or whatever. I'm showing you evidence to support the things that I am saying, the statements I'm making. And I think I can support the fact that this is dark matter. Okay, by the way, that's light spinning. It looks just like a drill bit. It's spinning to the right. All right, those are the electron showers coming at us. Alright, I just showed you the electron showers coming at us this way. Looking down, we can see that the black balls have separated from the electrons. And let me show you what CERN has to say. Okay, they just never realized what they have been seeing. The muon is the dark matter. And that's the black ball. It's a regular, well-defined circle. This is the electron showers. I showed you all those radiant color-looking things coming flooding at us. High-voltage electrons are. This is Cherenkov radiation. It's a high-energy radiation slamming into a medium that makes it concuss. And these just go off on their own, the little black balls, and these just turn into showers of electrons because their electron energetic particle is slamming into all the other energetic particles. It's like a cue ball hitting a pool rack. Boom, they go flying. That's exactly what you got. All right, let's finish it up and sum it up. That's the red laser pulsing. That is the red laser accelerating. That is the particle that comes as it accelerates just prior to hitting the venturi. That is the venturi that forces the acceleration. These are the particles that are coming out of the venturi, which are electron showers. That is the light slowing down, spinning to the right, drifting to the left. This is an unknown particle, which could be extremely interesting to CERN or anyone that was really interested in this. Now, so that's what I'm saying is all the different things that I have shown, and I am saying that this very clearly shows that that particle separated. When it came here, it was like this. It's now in pieces. And we can see that the pieces come back only here. Now, that means to me that this is a completely separate particle from the white. That's what I'm seeing. All right, you might remember I showed you this. This is the same as that. This is in space. Oops, and these are, this is ionized gas, really, within a vacuum type chamber, and they introduced dust, and the dust took on this charged nature, exactly like that. All right? On Earth, you wouldn't get this, you wouldn't get that. It would flatten out. And they explain it. We're going to go into this in great detail because I'm really enjoying it now. I have to go and explain every single thing that there is using electron flood theory. And I have so far, 100%. Gravity is fully understood now. The dark black matter is the gravitational particle that pulls them together. That's why you see these photons congealing into their little boxes. Now, we're going to go into this in some serious depth, though. Now, if you want to get ahead of this, get in and start looking up states of matter and how. Take notice of that they change state at different temperatures, at different pressures. All right, it's everything that I'm going to ever talk to you about will relate to electron flood theory, and it is push to shove. That's the only thing that creates energy. Outside of that, there is no energy. Okay, you won't get into this yet. We're just setting it up and getting it ready to go. But we're going to have everything up here under these tags, and if you click on it, it'll bring you to this, and if you click on that, it'll bring you to the light, and so forth. And the stunning soft tissue preservation, and tales of the past, ancient history. Now, it's up to you if you want to come up and look at this, but it'll be mudfossils.com. You won't get in yet, but I'm hoping within a week or so. All right. Thank you. God bless you. I hope this works out for everybody.